Hi everyone, it's ZF Mazibuko speaking. Let's continue with Engineering Science N3 for Report 191. And we are going to do Module 4, which is Friction, Part 2. We're going to use the same book as we used before, Engineering Science N3 book by G. Olivier, and the previous question paper for November 2018. Let's continue with deriving the formulas for the incline planes. If you've got your plane that will be an incline or that will be making an angle with your horizontal, your weight will no longer be perpendicular to your incline plane. You will construct the force that will be going down, which we are going to call it the perpendicular weight component, and the force that will be parallel to your incline, that we are going to call it the parallel weight component. So I've put that force here because this shows clearly that this force is parallel to your incline rather than putting it here. I've put it with the dotted line so that you can see that I've constructed here as I want to get a triangle. So now you will be having the perpendicular weight component going down and the parallel weight component that will be parallel to your incline plane. Now you've formed a triangle. So you will have an angle that will be equal to your incline plane and your weight. So now how do we get the magnitude of the forces? For the perpendicular weight component, this part, this force, this side will be an adjacent side to your angle that will be here. So now you check the trig ratio that we'll be using, adjacent and the hypotenuse side, which will be your weight. So now that will be the cos of theta. So its magnitude will be W the cos of theta. So this means that your perpendicular weight component will be equals to W the cos of theta. So for this side, which will be this one parallel to your inclined plane, this side will be opposite to your angle. So now the trig ratio that we'll be using opposite and the hypotenuse side will be sine theta. So the magnitude of this side will be W, the sine of theta. So now, how do we get the magnitude of FA, or how do we calculate the magnitude of FA? FA is the force that pulls this object up the incline, but parallel to the plane. If you look at FA is going up, it will be opposed by FU and the W sine of theta, which are two forces going down. We'll take these forces as the parallel forces and as the horizontal components. So your FA will be equals to FU times by W sine of theta. And your perpendicular forces, your NR is opposed by W the cos of theta. We'll take them as the vertical components. So we'll make FU the subject of the formula from the horizontal components. Your FU will be equals to FA minus W the sine of theta. And we are going to take our universal formula, the one that we used to derive the formulas for objects in the horizontal surface. Fu equals to mu times by the normal force. So instead of the frictional force, we're going to substitute by Fa minus W the sine of theta equals to mu, which is the coefficient of friction, into, instead of NR now we're going to put W the cos of theta. So your formula will be Fa, which is the pulling force, equals to the coefficient of friction times by W the cos of theta plus W the sine of theta. Now I want you to take this object now down the incline. So it means your Fa will be going down and your Fu will be going up. Now I want you to derive the formula to get the magnitude of the force that will be pulling this object down the incline but parallel to the plane, and check what will happen to this sign. Let's take the second part, where now we are pushing this object up the incline. When we are pushing this object, that pushing force will form an angle that we are going to call it alpha with an angle. It's no longer going to be parallel, but it will form an angle that will be angle alpha. So now you will have an angle and the hypotenuse side, which will be your FA. Again, you have to construct your triangle as I've constructed here. So you will have the vertical component, which will be your perpendicular force, and again the horizontal component, that will be your parallel force. How do we get their magnitudes again? For this vertical component, it will be opposite to your angle. So now the trig ratio that is using opposite and the hypotenuse will be sine alpha. So the magnitude of this vertical component will be FA, the sine of alpha. So for this horizontal component, which is again the parallel force, this side will be adjacent to your angle, which will be angle alpha. So to get its magnitude, we check the trig ratio that will be using adjacent and the hypotenuse side. So that will be cos alpha. So its magnitude will be FA, the cos of alpha. If we are pushing this object up the incline, your frictional force will be pushing it down the incline, opposing FA, the cos of alpha. And you'll have the parallel weight component, that will be W, the sine of theta, and the perpendicular weight component, that will be W, the cos of theta. And we're going to take the perpendicular forces as the vertical component. So your NR is moving towards north, opposed by FA, the sine of alpha, and W, the cos of theta. So your NR will be equal to W, the cos of theta, plus FA, the sine of alpha. And for the parallel forces, you will have FA, the cos of theta, which is this force, going up, still opposed by FU, plus W, the sine of theta, going down. This force and that one. So again, you are going to make FU the subject of the formula. So FU will be FA, the cos of alpha, minus W, the sine of theta. We'll take the universal formula and derive the formula, so which we can use to get the magnitude of the force that would push this object up the incline, but making an angle with that object. So we'll take FU equals to mu times by NR. Instead of FU, we're going to substitute by FA, the cos of alpha, minus W, the sine of theta, equals to mu into W, the cos of alpha, plus FA, the sine of alpha. This is the formula that we can use to get the magnitude of this force. Now I want you to pull this object up the incline. So it means your FA will be making an angle with the object here. And do all the construction and derive the formula to get the magnitude of that force that will pull this object up the incline, and check what will happen to the sign again. Yes, I've done that for you. Here, it's my applied force, which will be my pulling force or the tensile force that will pull this object up the incline, but still making an angle with the object. So again, I will have the angle as angle alpha, and I will construct the parallel force and also the perpendicular force. So the magnitude of this perpendicular force will be FA, the sine of alpha, and the magnitude of this parallel or horizontal force will be FA, the cos of alpha. And again, I'm going to take the forces that are in the vertical components. Those will be the perpendicular forces. Now your NR together with FA, the sine of alpha, are towards your north, opposed by W, the cos of theta. So your NR will be equals to W, the cos of theta, minus FA, the sine of theta, when you are making NR the subject of the formula. And let's check the parallel forces, that we take them as the horizontal components. Your FU together with W sine theta will be going down, opposed by FA, the cos of alpha. So FU plus W sine theta equals to FA, the cos of alpha. Then you make FU the subject of the formula again. So your frictional force will be equals to FA, the cos of alpha, minus W, the sine of theta. And again, we are going to take the universal formula, as we call it, which is the frictional force equals to the coefficient of friction times by the normal force. Instead of the frictional force, we substitute by F8, the cos of alpha, minus W, the sine of alpha, equals to mu, which is the coefficient of friction, into, instead of NR, which is the normal force, we're going to substitute with W, the cos of theta, minus FA, the sine of alpha. So now we've got the formula to get the magnitude of the force that will pull this object up the incline, but making an angle with the object. If you check, the sign now has changed. It's no longer positive, as if we were pushing that object up the incline. So this means that if you are pulling this object up the incline, the force on this side will be negative, and if you are pushing it, it will be positive, as we've seen before. Now let's take the questions. This one is from your textbook. We'll take number 3 on page 23 of module 4. We've got a body with a mass of 50 kg that is placed on an incline that is making an angle of 20 with the horizontal. You've got the coefficient of friction, which is 0.4. And here we have to calculate the magnitude of force required to push the body up the plane. And you are given the diagram that shows everything that is there in your statement. Here we'll have your normal force going up, your weight. So your 50 will be multiplied by 9.80 to get your weight. And you'll have that force P that will be pushing this object up the incline, and it will be making an angle of 30 with your object. Let's check another forces. Now this is the diagram after we've constructed everything. So here we've got the normal force, your perpendicular force, that will be equals to W, the cos of theta, and you'll have your parallel force that is equals to W, the sine of 20. And again, you'll have your frictional force, which is your Fu, and you'll have the constructed forces that will form a triangle. So to get the magnitude of this force, again, we are going to use the trig ratios. So this force will be P, the sine of 30, and this one will be P, the cos of 30. So now, please identify all the forces and write it on your diagram. Then again, we are going to take the sum of vertical components and the sum of horizontal components. After you've labeled your diagram, you will see that your normal force will be opposed by the force going down, which will be P, the sine of 30, and the perpendicular force, that will be W, the cos of theta. So now you have to substitute. Your NR going up will be opposed by 50 times by 9.8, the cos of 20, which will be your perpendicular force, plus P, the sine of theta, which will be this force. And for your frictional force, or for the parallel forces, that we take them as the horizontal component, your Fu, which will be your frictional force, which will be this force, plus W, the sine of 20, which will be equals to 50 times by 9.8, the sine of 20, will be opposed by this force. And this force will be equals to P, the cos of 30. So making Fu the subject of the formula, you will have P cos 30 minus 50 times by 9.8, the sine of 20. So getting the magnitude of P here, P will be, Fu will be equals to 0.866P minus 167.590 for 50 times by 9.8, the sine of 20. Then we have to use the formula, the universal formula again. So instead of Fu, we'll just substitute by 0.866P minus 167.590 equals to your frictional force you were given, it was equals to 0.4. Then your normal force is equals to 460, which is 50 times by 9.8, the cos of 20, plus the sine of 30 is 0.5, then P. So you will open the bracket, then you'll get 184,18 plus 102P. So it means you will multiply 0.4 by 460.45 and you'll get 184.18. And again you will multiply 0.4 by 0.5 and you'll get 0.2P. Then you collect the like terms. Here 0.2 was positive, so now it will become negative, and you transpose 167.590 and it will become positive. So you divide by 0.666 both sides. This side will cancel and this side will be 351.77 divided by 0.666. So the magnitude of P will be 528.183 Newton. Let's take another workout. Here we have to give two disadvantages of friction related to engineering. Your answer will be, it can cause tear on wear and it needs more power or more force, so it means there will be too much power loss. B, you've got a body with a mass of 60 kg that is placed on an inclined plane, making an angle of 20 with the horizontal. And again, you are given the coefficient of friction, that is 0.4. And the force F at an angle of 30 to the plane is required to pull the body up the incline. Remember, we're pushing this object up the incline, but now we're pulling it up the incline. So, what do we need to calculate? The component of F parallel to the plane, B, and the gravity component parallel to the plane. So, if you've got the pulling force Fa, like it is making an angle with the object, you will do the construction as we've done before. You will have this force, which will be the adjacent force to your angle, and this force will be your opposite side or the opposite force to your angle. So now you will have the triangle, and you need to get the magnitude of this force, which will be the perpendicular force or the force opposite to your angle, and this force will be parallel to your inclined plane, and you have to get its magnitude. So let's take A. For A, you have this force, and the magnitude of this force will be FA the cos of 30. I think you've get that from what we've did before, how to get the magnitude of this force. B, for the parallel force or the parallel weight component, that will be W the sine of 20, which will be 60, which is the mass of the object, times by 9.8 the sine of 20. Then you'll get 201.108 Newton. Now we've got to see where we have to calculate the parallel. Sorry, there is the mistake here. It should be the perpendicular weight component. That will be W the cos of theta, such that your 60 times by 9.8 cos 20 will be equals to 552.540 Newton. And D, we have to calculate or to get the magnitude of F. And even here, we're going to take the sum of vertical components and the sum of horizontal components as we've done before. So for the horizontal components or for the parallel forces, your FU together with W the sine of theta, they are moving down. They are opposed by FA the cos of 30. So you will make FU the subject of the formula. So FU will be equals to FA the cos of 30 minus W the cos of the sine of 20. So the sum of vertical components, your normal force plus FA the sine of 30 will be equals to W the cos of 20. So your NR will be equals to W the cos of 20 minus FA the sine of 30. And we'll take our universal formula, then you will substitute. Instead of FU, you will have FA the cos of theta minus W the sine of 20. And your mu will be 0.4 times by W the cos of 20 minus FA the sine of 30, which is for the normal force. Then you'll get the magnitude of cos 30 and the magnitude of W the sine of 20. You've already got it. You take it and substitute it here. Then your coefficient of friction and W cos 20, you've already got it. You take it and substitute it here. Then your sine 30 will be 0.5 FA. Then you open the brackets with or multiplying with 0.4. So you'll get 221.016 minus 0.2 FA. So you'll collect the like terms. 0.866 FA plus 0.2 FA will be equals to 221.016 plus 201.108. So you add this part, you'll get 1.066 that you will divide it by, or that you are going to use it to divide both sides. So it means you are going to divide both sides by 1.066. So this one will cancel this one. So for this side again, you will add these two, you will get 422.124, and you'll divide by 1.066 in order to get the magnitude of FA. So your FA will be equal to 409.673 Newton. That is the end of module 4, which is friction. Thank you very much for listening. Please practice a lot so that you'll be perfect and so that you'll get or you'll pass your examination. Thank you. Goodbye.